Hey folks, well, to round out the first week's material, I just wanted to get a little bit of time in where we're actually looking at some C++ and beginning to introduce the syntax, the layout, some of the general rules for our C++ programs. And of course, we're just going to get into more and more detail and more features as the semester rolls along. So it's kind of where I want to go today. So I'm going to talk through some of the theory and the ideas, and then we'll pull up some code examples and actually show you the sort of cycle and try writing a little bit of code here towards the end. So there's where we want to go. And again, this is just a very preliminary look. I'm going to introduce some things and not talk about them in too much detail. Again, we'll get in much more into the workings of things starting next week. So I'm assuming that this is brand new to folks. I know there are some of you who have got programming experience already, and some of you who've got specifically C++ programming experience already. I'm gonna suggest that you use that experience as a way to kind of get good easy marks for the first half or so of the course, where you're going through and focus on producing high quality code, well commented code. Do continue to attend the lectures to make sure that you're keeping up, to make sure that you're not missing anything. One of the issues that I've found in the past with folks who've already got some experience is you kind of go through those first few weeks of the course going, I know this, I know this, I know this. It's all old stuff. And too late you realize that I've actually moved on and am into things that you didn't know, or into doing things that you hadn't previously worked on. And at that point, all of a sudden, you're scrambling to catch up and figure out what's going on. So, hopefully it won't be too terribly boring, but I would recommend staying kind of with the class as we go our way through this. And again, for those of you who are brand new to this, don't worry, that's kind of what I'm assuming as we go in. So I want to talk first off about the overall structure of a C++ program, and I'm going to describe it in kind of 5 basic parts. So in the beginning, there'll be a bunch of instructions that are for the compiler, that aren't so much C++ code, if you like. They're instructions to the G++ compiler that we're going to use on things that we want it to do while it's compiling our code. And so we'll talk about these preprocessor directives, things that we want the compiler to do before it gets onto the actual meat of its compilation, its translation process. And some of those will get fairly obvious as we get into them. Then, if we're going to use any special kinds of data or any special values, we'll include definitions for those next. And then, one of the things that we can do in a programming language is to create subroutines, little blocks of code that have a name and that do something for us. Go check a password. We might create a little subroutine to check a password, and when we want to check a password, we'll run that subroutine and give it the password we want checked. So this is the kind of idea. And what we'll do as kind of the third piece of our C++ program is really just give a list of these subroutines that we're creating and a little bit of information about them. Then we'll have this main routine, and you might remember seeing that in the examples we were looking at last time around. The main routine is where the execution of the program really begins. This is central control, if you like, for our program. And each of our programs is going to have one of these things. And so that'll be the fourth piece of our code. And then the final chunk will be the full definitions of all those subroutines we said we were going to create. So we'll have a list of them up above, and then after the main routine, we'll have the full versions of these that have got all the gory details on them. So this is going to be the rough overall structure for our C++ programs. And I'm going to include that in the code standards with a little bit more detail and get you to follow this structure for our code. And again, we'll talk about the motivation for laying it out this way later on. All right, in the beginning though, we're going to start off with a very small subset of C++, and we're not going to really need all that much of all those different sections. So in the beginning, that first section where it's instructions to the compiler, all it's going to be is a list of what code libraries are out there that we want to make use of. And I'll talk about the syntax for that and what it means in a little bit. In the beginning, we aren't going to create any special types of data, but we might wind up using some special values. You know, we might decide that we've got a value we want to use for pi or something along those lines. So we'll create some special constants in that second section. We won't be using any subroutines in the beginning. So in the beginning, we won't have any of these short prototypes and we won't have any of these full definitions. It's just going to be a list of the libraries we want to use, a list of any special values we're going to use, and the main routine is pretty much where we're going to start. And then we'll add the other pieces in as we get further into the term. So that's what to expect for the start. And again, we'll show you some code. So in this particular example, we've got a small C++ program whose purpose is actually just to print a single line of output that says, hey, it works. Now, this first line up top is called a comment. It doesn't affect the execution of the program at all. It's more or less a software developer's notes to themselves. Right? Just in here, we can go through and include an explanation of what a program does or what a particular chunk of code does. And again, it's really just something so that if there's a cryptic piece of code or a piece of code that needs explanation when we're editing it, we'll put them in these comments. And again, what happens is the compiler just kind of strips these things out and ignores them. But when I'm looking at my code, I can read it and go, oh yeah, that's what this is all about. So we can throw comments in and we'll talk about that extensively as we get into the term. This is one of those examples of an instruction to the compiler. A preprocessor directive is what we'll refer to them as. And they begin with one of these hashes, and then there'll be some kind of instruction, and then the data that goes along with the instruction. So this one, hash include, means I'm telling the compiler to go off and find an existing C++ library, something that's already been written and included by somebody else, or written and developed by somebody else. And these angle brackets say, okay, here's the name of this pre-built library. And the one that we've got here is C standard IO. It's actually for the C standard input and output library. And that includes a definition of the print routine that we're going to be using down here. So we tell the compiler about any libraries that we want it to include, and it goes off and finds the code from those libraries and includes it when it's building our program. And then the main routine that I was talking about. Now, I haven't talked about the syntax here for creating a subroutine. In general, they'll have a kind of data that the subroutine is going to return to the rest of the program while it's executing. Don't stress that for now. We'll talk about that very shortly. The name of the subroutine, a list of any data that it's going to be accepting as parameters. Again, don't worry about it. We'll get into talking about those as we talk about creating subroutines and using subroutines. And then all of the instructions within the subroutine are enclosed within these curly brackets. So the main routine instructions begin here and end here. So in this case, the first instruction is a print instruction that basically says, print, hey, it works. We'll talk about, again, the syntax for this in a moment, but we've essentially got double quotes around whatever text is supposed to appear on screen. And then to end the instruction, we've got a semicolon saying, that's the end of this instruction. Maybe there's more instructions coming up. And then the next instruction, main routine can actually return a status value saying whether things went well or not. 0 is the kind of default, everything went okay. So I'm going to get the main routine to return 0 and say, yeah, this seems to have worked okay. So here is our main routine. 2 instructions, a print instruction and a return instruction. So when this thing gets compiled, it produces an executable. When we run the executable, all the executable should do is print this message, hey, it works, and then a new line at the end of it. So it prints, hey, it works, and then goes to the start of the next line. And again, in terms of the syntax rules, the grammar rules, we'll discuss these at length as we run through the semester. They are simpler There are fewer of them than the rules for natural languages, but the compiler is very strict about enforcing them. Right? If your program is not exactly correct grammatically, then the compiler will generate an error message and it won't produce a new executable for you. So if you've done things like, as we looked at in one of our earlier videos, if you've put a typo in here and you've used the wrong name for main, or you've used the wrong kind of brackets for the parameter list at the end of main, or you've used the wrong kind of brackets to enclose the list of instructions, or you've forgotten a semicolon, or you've used the wrong name for printf, then it will complain. It'll tell you that's not grammatically correct. It'll produce an error message and it won't compile for you. And so you wind up going through that edit, compile, execute cycle that we talked about before, where you just keep going back and fixing your file and recompiling and fixing and recompiling until eventually it compiles cleanly. So we'll talk about syntax rules for each of the different features that we introduce, but a few general ones to get started. So if you want to use things from an existing C++ library, then you have to include the library that contains them. So again, that printf routine that we were using is in this csci.viu library, so we have to include that in order to use those print routines. Our programs have to have a main routine in them, right? And this is, again, going to be where the program execution actually begins. The statements within the main routine have to be enclosed in the curly brackets and separated by semicolons, right? After each instruction, we'll have a semicolon to terminate it. And one thing to note is that the words in the language are case sensitive. So if I was to type main with an uppercase M instead of a lowercase, the compiler will yell at me because it's expecting a routine called main that's all lowercase, right? Or if I typed main M-A and then capital I-N, again, the compiler would yell at me because that's not the name it's expecting. So you have to get not just the spelling of the different words right, you also have to make sure you get the capitalization correct. And again, we're going to be going through this cycle, as always, of edit, compile, execute. And we keep editing and compiling until we get a clean compilation, and then we try and execute and see if it actually does what we want. So in this first case, assuming that I had no typos in it, it should just print, hey, it works, and then end. All right, so let's see if we can actually give that a try. And what did I call it? I called it firstprog.cpp. So at the moment, we don't have a firstprog.cpp, so let's create one, firstprog.cpp. And so again, I'm going to have my hash include csci.viu. I'm going to have my int main. And then inside it, I'm going to have whatever instructions I want to run. So I'm going to have my printf of, hey, it works. And that \n is telling it to produce a new line after it prints out, hey, it works. And then I'm going to have it return 0. And so, again, hopefully I haven't got any syntax errors in this. I compile it. So G++ is the compiler, firstprog.cpp is the name of the thing I want translated, -o, and the name of the executable I want to create. So let's say firstprogx. And it compiled cleanly, so that means that G++ thinks that it is indeed syntactically correct, and I can try and run the beastie. And it works. Let's experiment just a little bit with some of the different things in there. If I had mistyped the name of my library, when I try and compile it, it tells me that there's no such thing as an stdio library. So again, you have to get the spelling right. As I mentioned, if I happen to use uppercase instead of lowercase for some of the names and I try and compile, it tells me that it can't find a main routine that's all lowercase, and that's because, of course, had a typo in the name. For my print routine, if I forget a semicolon, I think we did this in the example in one of the earlier videos, it yells at me telling me that it expected a semicolon before the return. And notice that it's not until it gets to the return statement that it realizes that, oh, we seem to be trying to move on to a new instruction, but you haven't ended the old one yet. And so we can go back and fix that. Oops. If I do things like, let's leave off the \n. So in this case, I'm going to say print it works. This is all syntactically correct, so it should compile. And this is an example where it compiles cleanly, but when I try and run it, you'll notice that it does print the hey, it works. So it kind of works, but it doesn't move to the start of a new line afterwards. So my next prompt from Linux is right at the end of that, which can wind up making things kind of tough to read, easy to miss. So again, this is one of those cases where it compiled okay, but it doesn't behave quite the way I want. So once again, it's back to the drawing board and fix the beastie. Oops. Fix the beastie. Remember to compile it because I've changed it. And then hopefully we're back to the point where it actually does what I want. So this is the kind of thing that we're going to be playing with. Now, over the course of, I guess, the next 12 weeks, we're just going to keep on introducing new C++ features and ways to use them, and the syntax that goes along with them, and the standards that I want you to follow when you're using them. And we'll just see how we go. All right, that should be a good place to leave this for now.